is time for us to get started. So obviously people are going to be at different places. I think most of us, certainly if we're following the ATPs, which is the annual teaching plan that is given out by the government, we would start with sequences and series. So some of you may have done some of the stuff that I'm going to do this evening, and some of you may have not. But hopefully by the time we get to the end of this course, you would have covered pretty much everything in your syllabus. I mean, there's a couple of things we may not be able to cover, but we'll be able to do that when it gets to revision. So tonight's lesson is all about the arithmetic term formula. And if you were, well, when you are in grade 9, 10, and 11, theoretically, your teachers shouldn't have shown you this formula yet. This is actually just for matric, but maybe some of you have a teacher that showed you this formula as well. So let's just start off by saying that when we talk about arithmetic terms or an arithmetic progression or an arithmetic sequence, we are talking about our normal garden variety linear number pattern. The same ones that we've been talking about in grade 8, grade 9, grade 10, and then obviously a little bit in grade 11, although grade 10 and 11, they don't really teach us anything new. So for some reason, we stopped calling it a linear sequence or a linear number pattern. And in matric, we call it an arithmetic number pattern. So the word arithmetic is just another fancy way for saying that our pattern is linear. Okay, and I mean, it says that over here as well. Okay, so if a pattern is linear, what does that mean for us? What does it have? What is unique to a linear number pattern? All linear number patterns have them. What is it? Does anybody know? No, let's just look at the chat. There we go. Nalwazi, perfect. Mikhail, perfect. Luam, 100%. Okay, so there is a constant difference. All right. Common is a word that we use when we get to the geometric patterns, Luam, but really it doesn't matter. The point is all of you are saying it has, the difference is the same. Okay, so that's really important. And obviously that difference differs depending on the pattern. Sometimes the difference is positive, sometimes the difference is negative, but it is the same difference between each and every single term. So the formula that you would have worked with before this would have been your grade 8, grade 9, grade 10 formula. Now, different teachers use different letters, but really it all means the same thing. And what you would have done is you would have seen it in the form Tn equals Bn plus C. All right, and we spoke about that a little bit in our previous lesson because we were talking about the first difference of a quadratic number pattern, which is linear. So what we do in matric is instead of us working with Tn equals Bn plus C, we work with a formula Tn equals A, that's this one up here, Tn equals A plus N minus 1D. And I just want to explain to you where it is that this comes from, because not all of us would have done this just yet. Before I explain where it comes from, I need to tell you what all the different letters represent. Okay, so A in this case represents our first term. Okay, so the first term of the pattern, the first Tn of the pattern. D represents your constant or common difference. N, we know, represents the position of the term. And Tn, we know, is the value of the term. Okay, so the value of the term in its nth position. All right, now, where does this come from? Let me show you. So let's pretend we have a linear number pattern, and the linear number pattern goes 3, 8, 13, 18. So when I say that to you, what I mean is the first term is 3, the second term is 8, the third term is 13, the fourth term is 18. So these are my n's, my positions, and these are my tn's, the value of the term in that particular position. Right? So another way to look at this is as follows. Okay, term number 1 is A. And in this particular case, it's 3. Term 2, which is 8, all right, is A plus 1 difference. Now, the difference between term 1 and term 2 is 5. The difference between term 3 and term 2 is also 5. The difference between term 4 and term 3 is also 5. Remember, we calculate the difference between terms by taking term 2 and minusing term 1. Or taking term 3 and minusing, whoopsie, that's supposed to be a minus, minusing term 2. So in this case, we would say 8 minus 3, or 13 minus 8, or 18 minus 13, and we would get a difference of 5. Okay, so back to this. Term 2 is A, our first term, plus 1 difference. So that gives us 3 plus 5, which is 8. Let's have a look at term 3. Term 3 is A, our first term, plus another difference, plus another difference. So that gives us A plus 2 differences. All right, so in this case, it's going to be 3 plus 2 differences, that's 5. So that gives us 3 plus 10, which is where 13 comes from. Okay, how do you feel about this? Is it making sense what I'm saying? Thumbs up, thumbs down, just checking in with you guys.
Let's see, it will be very nice. Yes, there we
Thumbs
go.
down, smiley faces, hang tens, whatever you want to show us. If it doesn't make sense, you're more than welcome to say so as well.
Yeah,
Okay.
looks like the majority is a yes.
Okay, cool beans. All right, very nice.
Remember to take screenshots if you want to go back to this and just, even though we are recording the lesson, but you're welcome to take screenshots. I think Vele has a question.
Vele does have a question. Vele, you're welcome to unmute your mic and ask.
So Vele, you only have to go where it says, you know, that mic thing on your left-hand side. You just have to click on it and it will unmute and then you can talk to us.
Okay, so just to recap what it is that I'm trying to say, in matric, we have a new formula. We don't use this one in the rainbow colors on the right, Tn equals Bn plus C, although it does simplify to that. We use the one that I have highlighted up here in blue for you, Tn equals A plus N minus 1D. We have to learn that A represents the first term of the pattern, so the first Tn. Right? D is the constant or common difference. N is the position of the term, and Tn is the value of the term in the nth position. All right, so if we have a pattern that goes 3, 8, 13, 18, our difference is 5, our first term is 3. So we would write the first term, term 1, as A, which is 3. We would write term 2 as A plus 1 difference. So in this case, it's 3 plus 5, which gives us 8. We would write term 3 as A plus a difference plus another difference, which gives us A plus 2 differences. So that's 3 plus 2 groups of 5, and that's where the 3 plus 10 equals 13 comes from. And so onwards and so onwards. So term 4 would be A plus, anybody want to tell me how many differences? How many differences would term 4 have? There we go. It would have 3 differences. Good. Well done. All right. So that would give me 3 plus 2 times, 3 plus 3 times 5. So that would be 3 plus 15, which is where my 18 would come from. So the reason that I am doing this is because it is very important for you at matric level to know that A is the first term, and that all patterns can be written, or all arithmetic patterns can be written in terms of A and D. So when they tell you the first term of a pattern is, they are saying A is 3. If they are telling you the second term of a pattern is, they are telling you A plus D is whatever it is. Okay, so we've got to get used to writing our arithmetic terms in terms of A's and D's, because this is something that they're going to expect us to be able to do. Okay, so term 4 is A plus 3D. So now do you see where the formula comes from? Let me go and grab it up here and copy it and bring it down. Right, so there, let's pop it over here. So our nth term matrix, oh, that is not what I wanted. Okay, let me just write it in. So our nth term, so Tn, the nth term, is A plus n minus 1d. Okay, so that is exactly the same as what I'm showing you over here. So A is the first term, and then n minus 1. So when it was term number 4, there were 3 differences. When it was term number 2, there were 2 differences. So that's why it's n minus 1 times d. Okay, so very, very important. The d is being multiplied into the brackets. Okay, so what will end up happening in a case like this is you will then expand those brackets using distribution, and then you will eventually get it into the same form as it is over here. So in other words, it has to eventually be simplified. So if I work out the nth term for my particular pattern, what I would do is this. Tn equals, remember the first term was 3 plus n minus 1, and my difference was 5. So my 3 is a separate term. It comes down to the next line, and now I'm going to distribute. So 5 times n is 5n, and 5 times negative 1 is minus 5. I'm not allowed to leave it like that. Okay, I've got to simplify. So what I'm going to do is bring my n term to the front, and I'm going to say 3 minus 5 gives me negative 2. So that's where we get the nth term from. Can you see how it has been simplified? Okay, so let's just have a look. Everyone's saying 3. All right, yeah. So yes, Yolanda's absolutely 100% right, okay? Write these things down in your notes, okay? Because when you write it down, it gives you, you have to write it down. You have to make the connection between your brain and your hand with what it is that you're writing. Maths is not a spectator sport. So I do want you to take down all the examples when I do them with you, because these are notes for you, and then you're obviously going to try the questions, right, when they come along. Okay, so let's go and have a look at this one. It really is exactly the same thing as what I've been telling you. I'm just going to go through it one more time, and then I'm going to give you guys an opportunity to try one. All right, so here we have got an arithmetic sequence. It goes 3, 5, 7, 9, so it's a super simple one. The first thing that they want us to do is determine a formula for the general term above. Now, in maths, we are not required to write down the formula like we are in science. In science, we have to write the formula, we have to substitute, we have to write our answer, and we have to put in our units. In maths, we're a little bit less fussy about that. But I think it's really important that you know which formula you are using, okay? Because first of all, they have used the word arithmetic, because there are different types of sequences. And then they have asked us to determine a formula for the general term. So by that, they mean the nth term of the pattern. Okay, normally what they would do in exams is that they would tell you in the form an plus c or bn plus c, or whatever the case is. All right, so they mean they want Tn equals a plus n minus 1d. So the first thing that we need to do is work out the, anybody want to tell me what's the first thing we need to calculate or establish?
The common difference.
The common difference, quite right, Rebotile. And what would it be in this case?
2.
Exactly. All right, so I am going to write Tn equals A is 3 plus n minus 1. And there's 2. Is that okay if I write in the rainbow pen? Can you guys see the yellow okay? That's it, good, yeah, 2.
The rainbow yellow, and I like it. It's good.
Is it okay? Is it visible?
Mm-hmm.
Okay, all right, that's fine. And now we're going to end up saying 3 plus, remember we're distributing, so 2 times n is 2n, 2 times negative 1 is negative 2. So our final nth term is 2n plus 1. Okay. Then if they ask us to find the value of the 50th term, okay, we can do it like this, right? So the value of the 50th term 50 is 2 times 50 plus 1. So in other words, what I'm doing is I'm just subbing straight in there, right? If I wanted to, I could also say the term 50 is A, which is 3, plus n minus 1. So that would be 50 minus 1 times my difference, which would be 2 in this case. And you'll see you'll end up with the same answer. I think this method over here is preferable because it's obviously a little bit faster. Okay, so that would give us 100 plus 1, which gives us 101. And of course, we would get the same answer here. We would get 101. How do you guys feel? Is that making sense? Yeah, thumbs up, thumbs down.
Yeah,
Yes, are we happy?
It
We're feeling
is.
good.
nice.
Nice. Any questions? Anyone got any questions they want to ask?
Now your time. Forever hold the peace. I'm looking. Ask you.
Okay. Oh, good, Vele. I hope it's making a little bit more sense to you now. Okay. All right, so it's just a new formula, but the whole idea is actually just the same as everything that we've already previously learned. Okay, so let's go on. Oh, how? That wasn't supposed to be like that. What's going on here? Why is it not? All right, let's just cover that. Okay, so what I wanted to do here was give you guys an opportunity to try this, right? So you don't have to do both of them, you just have to do one of them. Now, what I did here is just to make the one a little bit more challenging is I've put a negative in here. So the first pattern, I hope you can see this clearly enough. The first pattern is -1. Why does it do that? 3, 7. And the second pattern is -99, -106, -113. Okay. I don't know what's going on with my computer here, but anyway, I'm going to do that. Can everybody see that okay?
Yes, we can see it.
All right. Okay, so what I want you to do is find the nth term of the pattern, all right, using Tn equals A plus N minus 1D, and then you're going to simplify it. Okay, so either do A or do D. You don't have to do both. All right, and I'm going to give you 3 minutes. Okay, so off you go. And again, if you've got any questions, just ask Yolanda and I. So you're going to do A or D. D is the difficult one, A is the easy one.
Let's go, guys. And just remember, please don't be worried. We know that load shedding is giving problem to a lot of you that you are connecting to audio and disconnecting. Just know and note that this will be posted after 24 hours. So tomorrow it should be on the Watobe link. So you should just get there and rewatch it if you want. So that will be great. So don't panic.
Okay, so Kamchelo, you say you've got 4n minus 5 and number 1. Is that wrong? Nope, it's not wrong, Kamchelo. Good, Snetemba, well done. Okay, you guys are flying through this. Good one, Louis. That's it. So since the first one is so, Snetemba's put an answer, okay. We'll see if Snetemba's got the right answer. And Rebotile is saying the same thing. Oh, no, not the same thing. Rebotile, you've got a different answer. Okay, Nolwazi says 10 minus 5. Nobasutu. Okay, so you forgot the negative. All right. Good, Luam. Yes, Lisoho. Okay, Lilita says minus 7n minus 92. Okay, Luam, you say minus n minus 92. All right, so let's just go and have, well done, guys. You've done that really, really quickly. That's amazing. Well done. I got a different answer for the second one, but I'm thinking perhaps I ended up making a mistake. But anyway, let's go and have a look. All right, so that was what I got for the first one. So -1 is A plus n minus 1D. So D was 4. So I think we all agree that that is 100% correct. Then for the second one, I got a different answer to you guys. Did I make a mistake? Which very definitely can happen. So, I did make a mistake. I'm so silly. Can anybody see what my mistake is in question D? I see my mistake.
Yeah, you added instead of
Yes, so
subtracting.
Lilita, my mistake here is that there was supposed to be a, sorry, I'm very silly. There was supposed to be a negative over there. There was supposed to be a negative over there. All right, so then this should have been 92. Oh, and it should be minus 92 as well, shouldn't it? Hang on a second, let's just fix that up. There we go. All right, so now it is correct. What I just wanted to, yes, that's quite right. Well done, guys. Okay, so something that's really important is for us to be able to go and find our own mistakes in our work when things don't add up to what we're expecting them to be. A little hint that I want to give you is that in the questions where your difference is negative, use brackets, okay, because it just helps to remind you that it's got to be multiplied in. I cannot tell you how many times in matric I've seen something like this, and obviously this is wrong. I'm just going to pop it on the side here. So this is wrong. Okay, but people do something like this. So they've got the minus 99 plus n minus 1, and then that's in a bracket, and then we've got minus 7. And then what matric students end up doing is going minus 99 plus n minus 1 minus 7. So instead of that minus 7 being multiplied into the bracket, it's being subtracted as a term. Okay, so that's why my suggestion here is, especially if it's a negative, make sure that you use brackets, okay, so that you don't end up making mistakes. Okay, good job, everybody. Well done. That's great. Okay, let's move on to the next concept, right, which asks us to determine which term of the sequence is equal to 80. So now what we've got to do is we've got to read the question. We've got to understand what sort of pattern we're talking about. Now, you see in this example, they don't tell us that it's arithmetic. Right, so they could do that to us as well. So we first need to establish, is our pattern arithmetic, and then you're going to do geometric sequences later on, or is it geometric? Right, then once we've established that it is arithmetic, we then have to interpret the question and know which formula to use. So now they say to us, determine which term of the sequence is equal to 80. So the English that they are using here is that they are implying that the value of the term is 80. So what letter in our formula is 80? 80 is which letter? It is our
Our TN.
It's our TN, quite right. Okay, it's our TN. Okay, so lesotho, that's a very common mistake. Okay, they're not saying to you, calculate the 80th term of the pattern. They're saying to you, which term of the sequence has a value of 80. So they are implying that the TN is 80. When they say to you, which term, they are asking you to calculate N. Okay, the other bit of information that we need is A, the first term of our pattern. And then, of course, it's our job here to go and work out what the difference is. Okay, so in this case, our difference is 3. Okay, so now we're going to be substituting into our formula. So Tn is 80. So we're going to write Tn is 80 equals A is -1 plus N -1 times our difference is 3. Sorry, I just always put it in brackets just in case. So now it is our responsibility to work backwards from 80 and work out the position of the term that is equal to 80 in our particular pattern. So we've got to bend our brackets. Be careful of signs. I'm going to leave my 3n this side because it really doesn't matter which side it is. And I'm going to take my terms all over to the same side. So it's got to be +1 plus 3. So that means that 3n is going to be equal to 84 in this case. And of course, now the next step is to divide both sides by 3. All right. Now, what sort of answer are we expecting? What do we expect this number to be? What do we expect here? What sort of number are we? There we go, Kumo. Okay, a natural number. Okay, so a real number or a positive number is not okay, because a real number, something like √2 is a real number. Something like 3/2 is a real number, a positive number. So, you know, something like 5,5 is a positive number. Okay, but that's not enough. It's not enough for it to be real and positive. It has to be natural. Okay, so what we are expecting here is a natural number. A natural number. And natural numbers are our counting numbers. Okay, so in other words, i.e., our counting numbers. So 1, 2, 3, 4, because remember, n is position. Okay, n is all about the position. Right, so what we have calculated is that term 28 is equal to 80. Okay, matrics at your level now, there would be a mark for subbing in. Okay, so a mark for subbing in, and then there would be an accuracy mark or maybe a CA mark on your answer as follows. Okay, so not worth a lot of marks, but the bread and butter of arithmetic sequences, we've got to be able to work backwards and forwards. How's everybody feeling? Are we good? Making sense? Any questions? Thumbs up, thumbs down. How do you feel? Good. Oh, good. I'm so glad. Nice. Good, Banolo. Good, Nobisuchu. Good, Yuanle. All right. Thanks, guys. I'm so glad that you're all feeling good about this. Okay. So now, again, an opportunity for you guys Hang on a second. Snokuhle, I do not understand. Is TN? No, September, TN is not the position. N is the position. TN is the value of the term in that position. Okay, so if we just go back up here and have a look, okay, so if I have a look at this example that we were talking about here, N, 3 is the value of the term because 3 is the term in the first position. 5 is the value of the second term, okay, because it is in the second position. All right, so 7 is the value of the third term because it is in the third position. So in the same way over here, oh, have I gone past everything? Tn is the value of the term, n is the position in the sequence. Okay. All right, so now here are a couple for you to try. All right, there's 3A and 3B. I would be very glad if you guys tried both of them. Okay, so give those a bash. What I'm going to do is just move it up here a little bit and just make it a bit bigger. You should all be able to see that. The first one, again, is the easier one. The second one is the more difficult one, but I'd like everybody to try both, please. Okay, so you've got, sure, let's give you guys 6 minutes, but let's see how it goes. Again, you can share your answers with us when you are finished. All right. That's fine. So if you've managed to get the first one, that's great. Go on and try the second question. Okay, so all right, a lot of you have done that one beautifully. Go. Perfect. N is 34. Good job. Yes, Nokushe, good. Well done. September, I just want to ask about your answer here. For A, you've said n equals 34, and then underneath you said n equals minus 122 over 3. What is that answer for? Okay, so remember, if you're writing an answer for n always has to be a natural number. Okay, because your position, you can either be in the first position or the second position or the third position. Okay, but now Modiba, can n be negative? Okay, but September, okay, so remember, n cannot be negative, so it cannot be a fraction and it cannot be negative. Absolutely, it's got to be a natural number. Okay, so if you get negative 122 over 3, it means you've made a mistake and you need to go back and go and see if you can make a correction to that. Okay, because remember, when we're working in maths, we need to know our theory so that we always have an expectation with regards to our answer. Okay, otherwise, our calculator can tell us anything. It will work out anything we tell it to, but it's not necessarily the right thing. There we go. So a lot of you are putting the answer 48 up. And that is indeed what I calculated it to be. All right, so there we go. There is the answer to the first one. So I've worked out that 94 is the 34th term in the pattern. And then as far as the second one is concerned, I got the same answer as you guys. And I got that n is equal to 48. So that one was a little bit more difficult. Did you guys remember to put the difference in brackets? Okay, I think that's really important when your difference is negative. And then remember, when you get your answer has to be a natural number. Okay, very, very important when we're working out n. Yes, Lolita, you've asked, raised your hand. You're welcome to unmute and ask.
May I ask?
Yes, of course.
Is it necessary to leave the 3 over 2 as a fraction, or can you convert it into a decimal?
You can convert it into a decimal, Lolita. It's no problem at all. So if you wanted to work all in decimals there, it's absolutely fine. I kind of had a mixture of things because, you know, the TN was a decimal, and then I wrote, I have a bad, well, not a bad habit, but my habit is to write things rather as fractions than as decimals.
Thank you.
But no problem at all. Okay. All right. Good stuff. So yeah, just again, at your level over here, there would be a mark for subbing in. I don't know, maybe you might get some kind of method mark along here, but I mean, if they give you method marks, then they can't give you continuous accuracy marks. So here it would probably be continuous accuracy, provided that it was natural. Okay, so again, subbing in, maybe a simplification mark, and then a CA mark based on the fact that it has to be natural. All right, so I think we're all feeling good about that. Are there any questions? Can I move on? Okay, so Kamugelo, what is it about question B that you don't understand?
You're allowed to unmute and talk to us, Kamugelo.
Absolutely. A fraction. So in other words, your difference here has been written as a fraction. And over here, your TN has been written as a decimal fraction. So this is an improper fraction. And this over here is a decimal fraction. Okay, so what is it that you didn't understand, Kamugelo?
It's fine. I just saw it now.
Oh, okay. All right. Okay, so you're all happy, Kamugelo?
Yes.
All
you.
right, good stuff. Okay, no problem. All right. So now let's move on to the next concept. Okay, so here in example number 4, what they do to us is this. They say to us that x, 4x plus 5, and 10x minus 5 are the first 3 terms of an arithmetic sequence. Cool, so they tell us that it's arithmetic. The first thing that they want us to do is determine the value of x. All right, so no exam or test should say, and hence the sequence. This is out of a textbook, and that's why they do that. But what they mean when they say the sequence, really, it's not a very good way of phrasing things, but what it means in this particular case is they want us to write down the value of term 1, term 2, term 3. Okay, so we are going to write down the value of term 1, term 2, and term 3. Okay, but the most important thing here is us working out the value of x. Okay, so if they want us to solve for a variable in maths, we need to make an, what do we need to make, matrix? They want us to solve for a variable. It means that we need to make an equation. Quite right, absolutely, perfect. We've got to make an equation. If we're solving for 2 different variables, then we're going to have 2 equations. All right, but in this case, it's just 1 variable, so we can have 1 equation. Right? Anybody got any ideas on how we would set up an equation in order to work out what x is? So Younger, I can see you've raised your hand. You're welcome to unmute and speak.
Hi, ma'am. In order to find x, I think we are going to say term number 3 minus term number 2 is equals to term 2 minus term 1.
Absolutely beautiful. Okay, so now, Younger, I'm so glad you said that. That is a formula that is not going to be on your formula sheet. So the formula Tn equals a plus n minus 1 is on your formula sheet. But what you've just told me now, you will only know if you've been listening to your teacher in class. Quite right, Nolwazi, quite right. Yeah. So that was supposed to be term 2. Okay, let's say, perfect. All right, so it comes from this. Your difference is term 3 minus term 2 is term 2 minus term 1. Now, the order in which you do this does not matter. So in other words, if I want to write term 2 minus term 1 is term 3 minus term 2, that's also absolutely fine. Okay, but this formula is not on your formula sheet. Right? So we need to make sure that we know how to do that. Okay, so term 2, the term 1 is x, term 2 is 4x plus 5, term 3 is 10x minus 5. Something that we don't do often enough, in my opinion, is to use brackets where it is necessary to do so. Okay, so I should have actually got my very important sticker and come and stuck it down here as well. All right, it is very important to use brackets. Okay, so I'm just going to add that in here and I'm going to show you why. All right, so use brackets. Okay, because the terms that you are subtracting are binomials. All right, so now we're going to go and we're going to sub in. So term 2 is 4x plus 5 minus term 1. In this case, it's x, is term 3, which is 10x minus 5, minus term 2, which is 4x plus 5. Okay, you've got to remember to use your brackets. The brackets here, so in other words, there and there, and there and there, are not going to make a difference. But when you are subtracting something that is a binomial, you must remember to use your brackets, okay? Because you are subtracting the 4x and the 5, not just the 4x. Okay, so now we can remove our bracket. So we've got 4x plus 5 minus x is 10x minus 5 minus 4x minus 5. Okay, so very important that we do this accurately, otherwise we're not going to get the correct answer for x. Okay, so now what we want to do is collect our x terms one side and our number terms the other side. I always write so big and I run out of space. So what I'm going to do is I'm going to bring this 4x term over here. I'm going to bring it down to the next line. I'm going to bring the 10x over, change the sign. Oopsie, I forgot about the minus x over here. Bring that down. And I'm going to bring the 4x over to the other side and change the sign. Now here I've got minus 5. I've also got minus 5. 5 needs to come over, so that's going to be minus 5 as well. Okay, so now how many x's do I have? I have 4 minus 10 minus 1 plus 4. So that's going to leave me with how many x? Minus 3x. Are you guys getting the same answer? Okay, and that's going to be equal to negative 15. So dividing both sides by negative 3, I work out that x is equal to 5 in this case. Right, are you guys getting the same answer? Good, yes, well done. Okay, so I'm sorry I ended up writing up here. I should actually be writing underneath where I am, but I'm going to go into my next example, and unfortunately I can't move that down. Okay, so remember your equals signs should line up underneath one another. Okay, good job. Yes, well done. Very nice. And hence the sequence. So now what they want us to do is they want us to go back and substitute in the value of x and work out what the first 3 terms in the pattern are. So term number 1, let's just change colors. That was x. So that means it has to be 5. The second term in the pattern is 4 times 5 plus 5. So 4 times 5 plus 5. And the third term in the pattern is going to be 10 times 5 minus 5. So that is going to give us, let's just get rid of this. And that. And let's just write everything nicely here. So the first term in the pattern, the sequence is 5, 25, 45. Okay, everybody happy with that?
Thumbs up, thumbs down. Let's see, like Teacher Leah can understand what's going on.
Yeah, so checking in again. Cool. Good stuff. Okay, I'm glad you guys are happy. So now the question that you have to do is this one over here. What I'm going to do is just make it a little bit bigger. My answers are underneath and I didn't cover them. So I'm not going to move down any further. If you can't get all the way to D, don't worry. We're going to try and do as much as we can before, I nearly said before the bell goes, before the end of the lesson. Remember, we've got to do a poll as well. So this just kind of pulls everything together that we have done this lesson. What I'm going to do as well, sorry, I should have got that. Control copy, and let's just paste this over here because you would obviously have that. Oh, putting my answers up. Control V, and then let's just put that over there. Okay. All right. So now you guys can try this question. Okay, ready, steady, go. Okay, I might have made a mistake, Lolita, but I didn't get that as my answer. Just check again. Okay, good stuff. If you work a little bit slower, don't be discouraged. Work at your own pace. I will reveal the answers in the end. Okay, Lolita, that's great. Yes, yes, yes. Good. Well done, everybody. So remember, determine the sequence means you just have to write down the first 3 terms of the pattern. Okay, so this bit over here, determine the sequence is a terrible question. You'll never get that in an exam. That's it, Luandle, Rosaria, Tuso. Good job, everybody. Good, Mikhail. Good, Rebotile. Good, Nobisutu.
Well done, guys. Just remember we have polls today.
Yeah. So what I'll do is I'll stop everybody in sort of like 3 minutes, and then, oh, maybe that's too much, maybe 2 minutes, and then I can show the answers and we can do the poll, and then I'll run across.
No problem.
All right. So Lucinda's already finished. Well done, Lucinda. That's great work. Obviously, the sooner you can get through these level 1, level 2 sorts of questions means the more time we have to spend pondering level 3 and level 4 problem solving questions. So that's great. I'm just going to give everybody another couple of minutes. If you're done, just double check your work and then we'll look at the answers. Okay, so Rebotile has offered an answer. Okay. All right, Rosario, you're getting a different answer to Rebotile for that one. Snetemba, you're struggling with B. Remember, you've got to go sub back in Snetemba. So once you've worked out what P is, go and substitute it back in. Okay, up here, this is where you're subbing it into. So once you know what P is, you're going to sub it in here, and then to the second term, and then to the third term. Okay, I can't believe how fast our time goes. Yes, Nobisutu, I think I got the same answer as you guys. Okay, so this is what I got. I also got that P was equal to a half. So I think that is correct. Then for B, the first terms of the sequence, so again, subbing in. So I got a half, 3, and 11 over 2. For question C, okay, so I got 241 over 2. So 241 over 2. Sorry, as I said to you, I always leave things as, yeah, so that is correct. That is 120,5. So either answer is 100% fine. Oopsie, 120,5. Cool beans. All right, so now some of you got 60 here. So I'd be interested to know if your A was a half, what was your difference? because you got 60 as an answer. Can you see your mistake? And then the last one, question D, they asked us which term in the sequence is 100.5. So we're going to make 100.5 equal to A plus N minus 1D. And then we're going to work backwards and work out what N is. So I ended up with an answer of 41. Oh, okay. Oh, good.